Okay, hi everyone. So I just wanted to show you a couple of things to do with natural restrictions on domain and range of functions. So if, for example, I type in this function, so I'm going to put in f of x is equal to 1 over x. Okay, and I'm sorry, I'm just going to set this up. My window is still pretty big from before, so I'm going to set up that up from -10, -10 to 10, and from -10 to 10. All right, there we go. Nice screen to look at there. Okay, so what you can see here, what's happening with this function, this is what we call a reciprocal function because it's 1 over x, and we're going to look at those a lot more in the next kind of couple of days, or probably actually after Easter now. What you can see is happening here is as x gets smaller and smaller and smaller and smaller, more and more and more negative, okay, f of x, or y, becomes smaller and smaller and smaller and smaller and smaller, and also more and more, but it also gets closer and closer to 0. And that's because if you imagine that you had 1 over, we'll say, -0.02, okay, that's equal to, oh sorry, not 0.02, 1 over negative, say, 100, okay, that's equal to -0.01. Now the other one that I was just going to say, if we had 1 over -0.01, that's equal to -100. So that would correspond to, if I zoom out again here, if we go down, if we find -0.01, that's all the way down at -100 there. So that point there, and if I click on it, you might be able to see, that point there would be, it says 0, but if I change the settings so that you've got lots of decimal places, so if I adjust those settings, if we say 4 decimal places, then that should change. No, okay, don't worry about it. Well, that would be at x coordinate -0.01, y coordinate 100. Okay, I think what's happened there is it's detecting the y-axis and not the actual line because the line's so close to the axis. Okay, all right, so if we go back up again, we'll look at what's happening on the positive side. So on the positive side, this graph is going from, again, when x is really, really small, y is really, really big and positive. So positive 0.01 would correspond to positive 100. And 100 would correspond to 0.01. Okay, so you've got that really, when you've got really big values, it corresponds to really small values. Now, what you'll also see here is that there is no way, the line does not cross that y-axis. And the reason for that is really simple. You've done it before when you were younger, probably. You've talked about it. You cannot divide anything by 0. So if you have, for example, what we're looking at, f of x equals 1 over x, okay, f of 0 would be 1 over 0. Now that cannot be true because it is impossible to divide by 0. Okay, and when you type that into a calculator, which I'm sure you've all probably tried to do at least from once or twice before, okay, 1 over 0 equals, you get a math error, okay, that doesn't work. So you can't do that, okay, so it's impossible. So that's why when you look at this graph, it's got like that break. It's got something happens as it goes up to 0, then it's got a break, and then it's got something that happens after 0. In graph terms, that's what we call an asymptote, and it's a natural restriction on the domain of a function. Okay, so for this, we would say the domain for f of x equals 1 over x. The domain of this is that x exists for all real numbers. Sorry, I had to just wrap that out quickly. So x exists. Oh, I lost my pen. x exists for all real numbers, so that's from negative infinity to positive infinity, with the exception of 0. Okay, and that's because you have that divide by 0 there. Now, if we go back to that graph, you can see that the range does much the same thing. So the range goes from, if we're looking at the vertical values, from negative infinity and then all the way up, bigger, smaller and smaller and smaller and smaller and smaller, break at 0, and then increasing from 0 and getting more and more and more and more positive and larger again. Okay, so our range for this function, sorry, no, why? Sorry, my hand keeps touching the God, sorry guys, that's terrible. Okay, so, what am I doing? Why would you not work? Okay, so, technology. Okay, so the range is that y exists for all real numbers, also with the exception of 0. Okay, now I'm going to show you one other kind of different example, and then we will, from there, take a look at some kind of combination functions as well. So the next one we're going to look at, which has a natural restriction, is the square root of x. So f of x equals square root of x. So if I go back to GeoGebra, I'm going to change this to being the square root of x. Now, before I type this in, try and think about what the restriction might be. What thing can you not have at this stage within a square root? So if I put that on, all right, and we can see that square roots are only positive numbers, and we know that, okay, they're only positive. And if I zoom in here, what you'll see is that we start exactly at 0, okay, it's possible to have the square root of 0, that's just 0, okay, and then from there, it increases and increases and increases, but it does not go negative, okay. So what we would say here is that our domain of f of x is that x is greater than or equal to 0, okay, and if you want to, again, we can put it in set notation, so we can have x as the set of x is greater than or equal to 0. And likewise as the 1 over x, y is much the same as well. Okay, so y can also be greater than or equal to 0. Okay, now I just want to show you a couple of different kind of combination ones. So ones we're going to look at, f of x equals 1 over x squared. And we're going to look at f of x equals 1 over x minus 2. And then we're going to look at f of x. So this is 1. Sorry, I'm doing this a bit all over the place. This is 1, this is 2, this is 3. And then f of x equals 1 over the square root of x minus 4. Okay, so that's what we're going to look at. So again, what I want you to think about in your head is what restrictions might be on 1 over x squared, or what might your domain and range be. Okay, so we know that for it to be a function, and because it's a fraction, we cannot have a value that's equal to 0. So that x squared cannot be equal to 0. So our domain is that x exists for all real numbers except for 0. Okay, range is a little bit different because by squaring that x, if that's a negative, that's going to make that still positive. Okay, y is still positive. So for y, we now have an extra restriction on the domain because y has to be greater than 0. Okay, not greater than or equal to 0 because it's not equal to 0, because then that would be impossible. But it has to be bigger than 0 because if we square a negative, that then becomes positive. So I'll show you what the graph of this one looks like. All right, we have f of x equals 1 over x squared. Okay, and we get this thing that looks like a tree trunk. Okay, and it is actually called a truncus graph, right? So it looks like a tree trunk. And you can see there that for y, doesn't go below into the negative y-axis. You've got that asymptote or that break at 0, and y then increases and becomes bigger and bigger and bigger as it keeps going. The next one, f of x equals 1 over x minus 2. Now again, we know that x cannot be equal to 0, but because you're subtracting 2 from x, that's going to change what makes that denominator 0, okay? Be careful, it's not just x that's 0, it's the whole bottom of that fraction. So we would say that x cannot be equal to 2 because 2 minus 2 is what's going to happen to make that 0, okay? So in this case, your domain is that x exists for all real numbers except for 2, okay? The range doesn't change for this one. So for range, that's just going to stay the same. So y exists for all real numbers except for 0. Okay, and we'll type that in and have a look. So, oh, wrong one. Okay, there it is. So again, same thing for y, comes up to 0, break, increases again. For x, you're now it's not changing at 0, 0, your break is at x equals 2. So we have it looking like that, right? The last one, you've got both a fraction and you have a square root. Ugh. I don't know why this hates me so much right now. It's been fine all day, and then like now it's decided that it just wants to give up and die. Okay, there we go. Alternative methods. So, f of x equals 1 over square root of x minus 4. So again, there's two things here which is just restricting the domain. One is the fact that it's a fraction. One is the fact that it's a square root. So again, this can't be 0 and it cannot be negative. So again, we're going to take x minus 4 and find where that does not equal to 0. Okay, so x cannot be equal to 4. Now, if x is anything less than 4, that's going to be negative and therefore it still also won't exist. Okay, so our function, our domain for our function is going to be that x has to be greater than 4. Okay, and for your range, again, that doesn't change. That's just y is greater than 0. Okay, so it should be bigger than 0. All right, I hope that kind of makes sense. While you're doing this, I would strongly recommend just having a play around on GeoGebra because, again, I think the software is amazing. I think it'll help you a lot to be able to do that and have a look at it. It's quite hard for you guys at the moment because you don't spend a lot of time graphing, so it's quite hard to work out what you need to have without knowing what things look like. But I think you should still be fine and just try your best. Okay, and let me know if you are really struggling and you have no idea what I'm talking about. Okay, all right, bye.